Okay, so these are the slides from today then. So you can pull them over from either the website or you can get them from the from your GitHub here. Either way, these are the slides that I'm covering. And so let's begin. We probably won't finish these slides today. We'll probably have to pick this up on Monday here. But I think, though, that we have the makings of a very good course here. And so I think if you can get through the Docker business here, the Docker part here, all that business, then I think that everything else is kind of like more or less smooth sailing in some crazy sense of the word. I've left my Docker. Actually, I've just done something that I told you not to do here, but I don't really care. I'm leaving my Docker container open, and that's okay. You can do that for the class. But if you're working like all day and you leave your Docker container open, then you might find that you run out of memory for when you game or something else happens. Anyway, so these are the slides I wanted to cover here, and so I wanted to talk about kind of we've all seen, and looking at the bottom here where it says bit, byte, field, record. We've all seen bits and bytes before. We all know that bits are ones and zeros, and we all know that bytes are basically arrangements of like maybe 8, 4, 8, or 16 words that are written in ones and zeros. But then we come into some other types of terms here. We have field, records, and files. We're basically getting to a larger and larger and larger scale of these bits and bytes here, or these bits. But we've all heard of files, or basically collections of records, which are collections of fields, which are collections of bytes, which are actually made up of bits. But at the very, very top of this whole thing here, we have databases. So that's like your next big kind of structural, if you will, data structure that you'd use for storing information. And so it makes sense to have this up here. But basically your database is at the very, very top of your totem pole here, in terms of like storage of information. Simply stated, the databases that we're going to be covering are essentially just tables. They're a series of whoa. They are a series of tables here. And these tables are going to be basically stored in a computer's memory. And to actually run a query from your database, that is to find information inside your database, you're going to be pulling out pieces of information in a table. And that's really, in essence, what a database is. A series of connected tables where everything is kind of found. So this is a not so simple database here. But again, these blue boxes here actually represent tables. Each table contains a different type of information. And if you look closely, I'm seeing like account, accountant, refund. I'm seeing some information that has specific types of meanings here. One of the things that you need to, that your muscle memory, your muscle memory in terms of databases, is that when you first see what's called a schematic or a diagram of a database here, you should be able to go from any one of these boxes to any other box. It's like a network here, anywhere in the network, from one point of the network to another point of the network, if you put your finger down in one box, you should be able to move from one box to another box or one table to another table without ever picking up your finger. Every box should be connected. You shouldn't have a disconnected graph, in other words, where you have some table which is just hanging out in space someplace. Because if you have a table which is not connected to the rest of the network of tables here, then that means you cannot access that table. It's as simple as that. It's kind of like, for instance, if you live in a house which has no driveway and there's no road that leads up to the house, then you really can't drive up to the house. If there's no road to the house, then you can't drive to the house. And so in this country, though, I think in this I was going to say in most places here in this country, most houses have driveways and roads that lead up to them, and so that's how you can connect those houses to the rest of the world. This is the same way here. If you think of each table as a house, they all have to be connected. Now, there is some vocabulary that we have to go through when we talk about what's going on in a table here. Along the very, very top here, and I wish I could point to this stuff here, but I can't. But I'm looking at the ID, name, department name, salary from this relational model single table diagram. Those are called your attributes. Your attributes are like your column headers. And then you have, for instance, basically, it's like a spreadsheet, if you will. But you have your columns, which we would call the like your observation classes, I guess. There's different ways of different books have different names for these things here. But in the books that we're using, in the book that we're using here, this is the vocabulary that they use. But if you look at another book on databases, the vocabulary seems to change, which is it drives me insane. But so the column headers are called the attributes. And then each row is what they call an observation. And that means that each row is basically a piece of information which could be ordered in some chronological way, where, for instance, every row that you go down is some point in time. Or maybe it's a different person, or maybe it's something else. But it's an observation. In many cases, they call them a table of observations here. And if you go into the columns, if you look down the columns here, all of those observations are the same class of observations here. So ID, all the stuff that we see on the left-hand side here, those are all numbers which are used to signify these, I guess they're employees or actually they're people, they're probably faculty in the departments. So they're IDs that signify what each person's, which pertains to each person here. And then you can see, for instance, in the department name, that's again the same class of information which concerns all the names of the people who are working in this campus. And so you can kind of see that rows of observations, but columns of single or similar data. So anyway, and then the column headers, don't forget, are called attributes. If you read another textbook, though, on databases, it's likely that they have different names for these things, but I will keep my appellation here very consistent, and so that we won't get lost. Now, these are two different types of tables here. You'll find that there's specificity in what kind of information is actually stored in each table. So, for instance, I'm looking at table A, which is called the instructor table. And the instructor table basically contains information about the instructors. Everyone, and that's part of the efficiency of the database. You want to keep each table kind of clean and neat and tidy here, and basically pertaining to one type of data. In this case, it's the instructors. Also, when you create data like this, when you organize your tables so that the instructors, anything that you need to know about instructors actually lives in the instructor table, then it helps maintaining that database. It helps it to be much, much easier to maintain that database. Otherwise, when you're maintaining a database which has tables, which is kind of like ramble and babble, if you will, it's very difficult to maintain or to maybe to trace errors that you may find or to write queries. Below, we have the department table here, and you can see that the department table and the instructor table, while you can see the common reference between both of these things here, the instructor table really concerns the people, whereas the department table concerns maybe the actual departments, and maybe in this case, there's the department name, the building, and then their budget that they have. And so it kind of makes sense. I think that I'm not saying anything here that's completely outrageously crazy. I think that once we see these things, it kind of clicks and it makes sense that you want to keep everything kind of neat and ordered. This is a table that I actually created all by myself, where we were having this, I made a database here because we were having a picnic. This is like, I think 2 summers ago, where we were trying to figure out who's getting what kind of sandwich. And so I thought, let's be really nerdy here and create a database to keep track of all the sandwiches that the faculty members were getting here. So we have people from CS, we have people from geology. Everyone in the building had a sandwich here. In fact, you can see that I had a peanut butter and jelly, a good vegetarian sandwich here. Not that I'm a vegetarian, but sometimes I tend to eat like a vegetarian. I see that JJ had a Reuben. Dr. Keffimer had a chicken sandwich. Dr. Mohan had a chicken sandwich. Actually, this is pretty juicy information, you got to say. I mean, it's quite exciting. You can see that they had sandwich here, and we were also having tea. And so I was keeping track of whether they're having tea or whether they were going to have like water or something else. And so you see that most people had tea. But this is the table that I put together just with this information here. And you can see that, for instance, I had basically 2 tables here where I needed to keep it this wasn't the most efficient table here, but it worked for what it was supposed to do. Where one table basically concerned where the stuff was supposed to be delivered, which is basically the department and the room number. That's for this catering group that we had. Actually, it wasn't catering, it was another group here in Meadville. And then we had to figure out what each person was actually ordering. So I created 2 different tables here. One table that concerned the sandwich order, and the other one that concerned basically where the sandwich, the sandwich was supposed to go. So that was basically the table that I put together here. And so once I finished my table, I met up with all my friends here, and we just all smiled and had thumbs up, and it was like just a great moment. It was just terrific. So Great. So now what I'm going to do is I'm going to take you through the steps. I'm looking at the time here to see how much time we have here, but I want to take you through the steps, basically about how I put together this database here, and I think that you'll see that it's really not a difficult thing at all. This class, I would say that everything that we do in this class is an extension of what we do today, which I know sounds like, an oversimplification of everything here, but essentially what we're doing is working with databases and building them. And so what we do today, everything we do after this, is an example of what we do here. So we're going to be using this database system here called SQLite. SQL stands for Structured Query Language. It's a very simple database that you can use to create seemingly any kind of general purpose applications for databases. One of the problems about SQL is, though, that it only allows one user at a time to interact with it. So the things we talked about last Wednesday when you have concurrency, that doesn't apply here. This is a database that's basically built for a personal level. But that doesn't change anything, though, because if you have an iPhone or a Samsung phone, those phones actually use SQL to look up names, numbers, and other information. Each time you store some information in your phone, how does the phone know where that information is? It uses a local database. And since you're the only person actually using your phone, then SQL works terrifically. It just works wonderfully. So this is a database management system on very simple terms here, but it does do seemingly the same thing that some of the most sophisticated databases will do. And that is that it allows you to store and access information. And you can program this thing. So we're going to be spending probably some weeks, I guess, going through programming SQL. And by the end of this, SQL will be on your SQL. I mean, SQLite is like SQL. It's the same language. And so SQL and SQLite can both go on your resume, and you will be amazed at how far and what kind of databases you can actually create. It's a relational database, which means that you have tables, and so you're creating things. And you can the part at the end here is probably the most essential information, and that is it's used to query, insert, update, and modify data, which is exactly what you want in a database. Let's go ahead and get this thing fired up here. Okay, so I have this command here, SQLite3 here, somewhere. Here we go. I'm moving ahead a couple slides here. Before I guess I could have put this further back, but there are a couple of ways you can do this. If you cannot get your Docker container working, then it's not a problem here. You can always check out this site here, which is an online SQL system, if you will. You can actually work with this here, and you can do your homework on this. You can actually play with your SQL from your browser. Close that. The disclaimer saying don't put any sensitive information up here, but we're not working with sensitive information. We're just learning how it works. But the commands all work. Now, when I'm working here, I'm going to be using my Docker container. If I can get back to actually, how do I get back here? Oh, I have to go back here. I'm going to be using my Docker container here, and so when I'm firing up my SQL3, what I'm going to be doing is I'm going to be going to my terminal here. I'm inside my container. I can see that by here. Also, when I'm inside my container, I can look at if your command is anything like your command prompt is anything like mine, it will tell you root right here, and so you can see that you're actually inside. But what I'm going to do is I'm going to type in SQLite. In fact, one of the things that I've put into your Docker file. Let me just show you something quickly here before I go. I just have to say this for the sake of being a nerd. This command right here inside your Docker actually installs that SQLite database. And so if you run this Docker file, it will install the database. And so I can type in SQLite3 per the slides here, and so you'll see that 3 has to be there. I don't mean to make anyone dizzy by switching back and forth. I do apologize about that, but it's one way of being able to show you my screen. Okay, so I'm inside this. One thing I should tell you, though, and it's very important, and I don't want to exit something as soon as I started here, but you really do need to know how to get out of SQLite when you're done, and you do that by typing .exit, and then you're out. Please do not, never, do not just click on the window, the X on the window, and kill the window. Don't do that. Don't do that, because when you do that, that means that anything that you've been working on, if you write a database in SQL, just like free-handed, like what we're going to do today, then it won't save. And when you type in .exit, it saves your work, and then it allows you to exit gracefully here. Excuse me. But if you don't save your work, or sorry, if you don't, if you just kill the window, then you may have things hanging in memory which are just basically dumped, and so you've lost everything. And so please do consider using our dear friend .exit here, and that will help you get out of everything. Now, let's see. Going back to my slides, what's next? When you first run your SQL, I think this is probably from an older version of my. I put these together on a different machine, and this is the version that I had. I haven't updated this machine in a while, just because it's I'm lazy, but it still works just the same though. The nice thing about SQL Lite here is that it doesn't really change that much. The language is more or less fixed. If you have a newer version than this, it's fine. It probably means there's less bugs. There's always bugs in software, but there's less bugs in your version than mine, presumably. But it should still work exactly the same way. So what I would like to do with you is to build this database. I'd like to recreate this crazy sandwich day where I had to make a database with people's sandwiches. And by the way, when I was at a faculty meeting, I told everybody, they said to me, actually our departmental faculty meeting, they said, so Dr. Bonham-Carter, you're going to be taking care of the sandwich orders. I said, yep, I've built a database. And as soon as I said I've built a database, the whole room just looked at me and their mouths were just open. They must have been impressed. Right? Isn't that what people do when they're impressed? They gape. Let's move to the data for a second here. Notice, I'll just leave these open here. You can see that this is the data we have here, but we have to kind of get an idea about what the data is actually doing here. So in this table here, you'll see that there's ID, department, and room number. My attributes, ID, attribute, department, and attribute room number. This is information that I want to store. And so I need to know what that information is, because when you are when you are designing, that's the better word, when you're designing a database, you need to have an eye on the data. It's like when you are going to the store to buy clothes, like a new pair of pants or something like that, you need to make sure that the pants you buy are actually in your size. Otherwise, they're not going to fit. It's a no-brainer, but the same thing is true with your data. You have to make sure that the data actually fits the pants of the database. No. You have to make sure that your data actually fits inside the database. You have to make sure that your database is actually built so that it accommodates the data. You're playing to the strengths of the data, and your base has to be able to allow that data to be used in a useful way. So you need to keep your eye on what you're dealing with here. For ID, I'm working with a string. For my department, it's another string, and room number I'm working with some kind of an integer, perhaps. But you can see that there's basically 2 characters for ID, 2 for department, and then 3 for room number. And so you need to know that, and you do that because if you create a database where you are just throwing together tables of any old size, then when the tables are small, it doesn't make a problem. But when the tables get big, or when your database becomes huge, then you run into memory limitations, and that's what makes your computer crash. And while we've all dealt with a crashing computer, perhaps we haven't dealt with a database which crashes in some Wall Street's company here, just as it's saving the information from hundreds of millions of dollars worth of assets. And so you don't want your database to crash, and so you want to keep an eye on the data. What kind of memory is it going to use? Here's the slide again. You can use this here. I'm going to be using my sandbox Docker file, or my Docker container to run this thing here. Equally, you could... I haven't put this in here. I will put a slide in there, and I'll put out a message in Slack, basically called Tools, which has some links on how you can download, if you're using Windows. You can actually download your own version of SQL, so it actually sits on your machine. So you just click on it as you would with your Word for Windows or whatever it may be. And so you can always run that. But as long as you have SQLite in some way, that's fine with me. But if you don't want to install anything here, then this online site is pretty good. Now, when we're creating our data, or our database, we have to create the schema, and the schema is kind of this construction of the tables. And so your table construction is going to have this type of script. You're going to have a keyboard here. The keyboards, I'm trying to write the keyboards in uppercase, but I think I might get sloppy later on. But for now, though, the uppercase terms are those ones which are actually relevant to creating your database. So you have to create a table. And what this amounts to is basically a place in memory, a data structure, if you will, a place in memory which is controlled by your SQLite management system where the data is going to be stored. It's a place in memory. It's very, very cool. So to actually create our table here, remember our table has to be able to hold this information here, ID, department, room number. So we're going to be creating a table here, and I'm going to call this department, but I'm going to call this, these are the attributes, remember. I'm going to call each of my places where I'm going to store my data by the same attribute that I actually have in my original table, ID, department, and room number. Somewhere right here. Excuse me. ID, department, room number, all that information is going to be stored in this code right here. Now, what this basically means is that I'm going to be creating a, I'll just copy and paste this actually. Hopefully I can do that. Copy and paste that. I'm going to go to my SQLite and hopefully it'll work. Okay, so I know that nothing amazing has happened here, but as long as it doesn't report any errors, that's okay. Now I can type in this .tables command here, and I can see what's actually inside my, what's in my database. So basically, what it's saying is that we have an empty database, but it's getting ready to receive information for department. If I type in schema, I can see that, and don't worry, we will be typing in .tables and .schema repeatedly here, and so don't worry about wondering or if you're never going to see these commands. If you don't write them down, you're never going to see them again. No, you're going to see them again and again and again. So .tables and .schema, you'll be using that to see exactly what's inside your database. But this is like your bird's eye view of what's in there. Every table that's going to be in there is going to have will show up if you type in .schema. Now. These tables are empty. That means there is no data in these tables just yet. And so we have to still populate them with something here. One thing I'd like to mention, though, is that varchar is a variable character. And basically what that means is it says, SQL, I don't know what this data is going to be. It's going to be a string or it's going to be an int. You figure it out when you see it. It's a very lazy way of doing this. It's memory intensive. It uses up a lot of memory here, so you wouldn't want to use this on mission critical databases, which are hundreds of tables long. But it's okay for the sake of discussion here. I think it works just fine. I'm trying to beat the clock here. The next command that we have is we're going to insert data into our database here, and so I'm going to. Not that I'm being arrogant here. I've just only realized that it's my name that's coming up here. OBC, CS, and by the way, 104 is my office. And so that's, I guess, my room number here. And so I'm going to be putting in this second line up here for OBC, CS, 104. All insertions are going to be very much the same. And so what I'm going to do is I'm just going to copy out this command here, insert. That's saying, okay, I'm going to give you some data. SQL, get ready. This into keyword right here says I'm going to be putting this into a particular table. This is the table that I've actually mentioned here. Remember, department is a table that we just created right here. And then values is the beginning of my tuple. And the tuple is this stuff right here. That's the data. Now, remember, OBC, CS 104, these pieces of information here absolutely must be in the same order as your table here. So my table was created with an ID first, and then comes the department, and then comes the room number. Because remember, the table isn't smart. It doesn't know that you're trying to put in a room number where an ID should be. It has no idea. To the database, the room number and the ID are just numbers. And so when you're running queries here, you want to make sure that your queries are actually receiving decent information here that actually conforms to what you're looking for. And that is that you want to make sure that the columns are filled properly. Now I'm going to I'll just copy this. I'm going to go to my table over here. I'll paste this in there, and it's done. Provided that no error messages came up. If I type in this over here, I get an error message. That's what an error looks like. It's actually sometimes it's useful to see what the error message is actually saying. It says that near this gobbledygook, there's a message, it's a syntax error, and so you can use that message here to try and help you diagnose. But again, if I type in schema, nothing has changed, but I do have data in there, but I can't see the data from where I am right here. And so let's go back to the slides here. What can I type in as a query to actually kind of get some information out? Well, your query is right here. And so this is in lowercase, so I should have had this in uppercase, select and from. What this is saying is select, that means basically go to the table here, which I'll name in a second here, but take out of the table everything, that's your wildcard, from this table here, department, and select everything. That's like your catch-all print statement. So I'm going to go ahead and copy this, just like that. I'm going back to my slides. I don't mean to make you sick by swapping back and forth like this, but there we go. And that's my first query. So I'm going to do something cool here. I'm going to change this around here. I'm going to say, just for the fun of things here, CS, I'm going to put, I don't know, James Bond. I didn't even know he worked here. Crazy. Now he does. So how do I find out that he's actually in my database? Same. Now you can see that I have OBC and James Bond. Wow, what an action-packed department you belong to. Cool. All right, so that's basically the gist. In fact, we've just actually got it done. It's 12:20 now. I'm about to go here. But basically, though, we have just built a database. And for the rest of the semester here, we're going to be going through and making, we'll be changing what we've just discussed here today and making things a little bit more sophisticated. But in absolute essence, we have created a database which is fully functional, and it now passes. And you can even create this database to, if you're having some kind of picnic with a bunch of your colleagues, by all means. They're always impressed when you make a database with what kind of sandwich they're going to be having for lunch. Who wouldn't be?